My name is Safwani binti Laha.
Hi, my name is Siti Nur Atirah binti Jafar.
Hello, I'm Dayang Nur Faizatul Fawaz binti Awang Omar.
I am Nurain Kristina binti Mazilat. Chapter 1, Introduction. Introduction. The saying "where there is a shadow, there must be a light" tells us that we need light source to generate a shadow. For example, our own shadow that constantly follows us around on a sunny day is generated by the sun. To cast a shadow, we need an object that can block the light rays. Not every object is able to do that. Some materials will let the light pass through, while others will only block part of it. Objects that can block all the light are called opaque and will form a shadow. We also need a wall or screen on which we can make the shadow visible. For problem statement, adjustable shadow size works only with shadows coming from a point source. Shadows look different and even take on different shapes when cast from different perspectives. Therefore, we want to identify what demonstrates that an object needs to be between a light source and a surface for a shadow to form. Research objectives for this experiment is to determine the effect of the distance between light resources and the opaque object towards the height of the shadow. Also to determine is there a significant difference between mean of the distance between light resources and object towards the height of the shadow. For a research question, is the distance between the opaque object and the light resources affecting the height of the shadow? And the other questions is there any comparison mean between height of the shadows in different distance between opaque object and light resources? Next, we proceed to the research hypothesis. Hypothesis number 1, H null, there is no effectiveness between the size of an object and the size of a shadow. H1, there is an effectiveness between the size of an object and the size of a shadow. Hypothesis 2, H null, there is no significant difference between the size and shape of a shadow by repositioning the light source. H1, there is a significant difference between the size and shape of a shadow by repositioning the light source.
Next, we move to chapter 2, which is method and materials. For description of design, in this research, we use the randomized complete block design, which is RCD, because the experimental unit is not homogeneous, but it may be sorted into a homogeneous group called a block. Furthermore, there exists a nuisance factor. For randomization procedures, first we need to define the treatments, and then we randomize the object shape sequences, and then we randomize the treatment sequences for each object shape. For materials, we use flashlight, screen, ruler, perfume box with the shape of rectangle, and then we use bottle which is shape of cylinder, bottle cap with shape round, and book with shape square. And we also need pen to list down our result. For method use, in this research we use randomized complete block design, which is RCD. Our experimental unit is flashlight. Our measurement unit in centimeter. Our number of replication is 4. Number of observation is 16. Our factor is distance between the flashlight and the object. Our treatment is 5 cm, 10 cm, 15 cm, and 20 cm, which is we have 4 treatments. And for nuisance factor is the shape of the object: round, cylinder, rectangle, and square. Our response variable is size of the shadow on the screen. Next, we move to experimental plan. Step 1, we prepare the material for conduct the experiment in one place. Step 2, we place the objects at a distance of 5 cm from the screen. Step 3, we place the flashlight at a distance of 5 cm from the object. Step 4, we turn on the flashlight and the shadow will form on the screen. Step 5, we measure the size of the shadow using a ruler and record the size. Step 6, we repeat the same step from step 2 to step 5 using another 3 shapes of object, which is round bottle cap, cylinder bottle, square book, and rectangle perfume box. And lastly, we repeat the same step from step 2 to step 6 and change the distance between the object and the flashlight to 10 cm, 15 cm, and 20 cm. For randomization, our factor is the distance between object and flashlight. We label it as A, which is 5 cm, B is 10 cm, C is 15 cm, and D is 20 cm. And we also have nuisance factor, which is shape of the object. We label it as 1 for round bottle cap, 2 for cylinder bottle, 3 for square book, and 4 for a rectangle perfume box. for the randomization, step 1, we need to define the treatment, which is 5 cm, 10 cm, 15 cm, and 20 cm. And then, for step 2, we randomize the sequences of the object shape. We use the random number in ascending from block 3. Okay, next step, we randomize the sequences of the running treatment for object shape 2, since object shape 2 placed first in the sequences of the object shape. And then we randomize the sequences of running the treatment for object shape 1. And then we randomize the sequences of running the treatment for object shape 3. And then we randomize the sequences of running the treatment for object shape 4. This is our final arrangement of the randomization.
In addition, let's move to chapter 3, result. First and foremost, the linear model of the experiment is equal to mu plus tau I plus beta j plus error, where error are identically and independently distributed random error following a normal distribution with mean 0 and variance. The expected treatment effect based on the experiment is expected MSTR equal to expected SSTR over SSE equal to 31.692. Where MSTR is equal to mean square treatment and the value obtained from the SSTR divided by SSE. Here are the results of the ANOVA table. Based on the ANOVA table, the test statistic of the significant difference between the distance of the light source to the object and the height of the shadow is conducted. The hypothesis is H0 equal to mu1 equal to mu2 equal to mu3 and equal to mu4. H1 is at least 1 mu I not equal to 1 mu j. Alpha equal to 0.05 where p-value is equal to 0.018. Since p-value less than alpha equal to 0.05, H0 is rejected. So, we have enough evidence to conclude that there is significant difference between the distance of the light source to the object and the height of the shadow.
Next, I continue with assumption of error. So, in this section, we have two plots which are normal QQ and scatter plot. So the first one is normal QQ plot. We found out that the residual distribution is normally distributed since all point lies along the straight line. The second plot is scatter plot. We can assume that the variance is constant since all points are randomly scattered and have no pattern. Since we conclude that there is significant difference in ANOVA result before, so we have been conducted the post hoc test for Tukey test and LSD test. This is because ANOVA table do not identify which particular difference between pairs of mean are significant. By using post hoc test, we will explore the difference between multiple means while controlling the experimental wide error rate. So this is the table for Tukey test. So for the analysis of Tukey test, the hypothesis is H0 is mu I equal to mu j. For H1 is mu I not equal to mu j for all ij. So for the critical value we found is 4.9602. Next, for the division rule, we have to reject H0 if the mean difference is greater than the critical value. So the conclusion is we can conclude that there is significant difference between mean of pair AC and AD. However, we found out that there is no significant difference with other pairs. Post hoc test that we conduct is SSD method, which is Fisher least significant difference method. This is the table. For the analysis of LSD method, the hypothesis for H0 is mu I equal to mu j, and H1 is mu I not equal to mu j for all ij. So the critical value for LSD is 3.7768. Where the division rule, we need to reject H0 if the mean difference is greater than LSD value. So we can conclude that there is differ significantly between the pair AC and AD, where the other pair we don't have enough evidence to conclude that there is significant difference between the pair.
We move to the last chapter, that is chapter 4, conclusion and recommendation. Based on the experiments, we can conclude that the size and the shape of the object can affect the height of the shadow. The closer distance of the light source to the object, the bigger shadow will be present. This is because the object blocks more of the light. Based on the data analysis that have been done using SPSS software, this experiment achieved the objective of the experiment. Hence, it shows that the greater distance of the object to the light source, the higher height of the shadow shown on the screen. This case study is recommended for the art designer that use shadow to draw their art on the right size. The more distance between the torchlight and the object, the smaller shadow size. The shape of the object will show on the screen and the people can follow the shape of the shadow to make the art. That's all from us. Thank you for watching.